Good morning, ma'am. My name is V. Sai from Triple E Department. Subject Performance of Transmission Lines and Cables. Subject Code AED18. Assignment Topic Cables Jointing Techniques for High Voltage Underground Networks. Cable jointing techniques for high voltage underground network. An in-depth technical presentation. Purpose of presentation. Scope, industry's relevance, learning outcomes. Purpose of presentation to provide an in-depth understanding of cable jointing process for high voltage HV underground networks, enhancing safety, reliability, and performance standard in modern power distribution. Scope covers fundamental types of joints, materials, stress control, testing, and best practice from 11 kV to 132 kV underground cable system. Industry's relevance. HV underground network forms the backbone of urban power grid, requiring precious and durable jointing techniques to ensure uninterrupted services. Learning outcomes. Attendees will gain technical insight into joint construction, installation techniques, and failure prevention strategies. Introduction and scope of HV cable jointing. Understanding the need and context. Global shift to underground power network. Urban expansion and elastic demands have driven the shift from overhead lines to underground HV system, enhancing safety and minimizing visual pollution. Complexity of underground HV system. Unlike overhead transmission system, underground network involves thermal and mechanical and electrical design, making a jointing a critical reliability and determinant. Scopes of jointing techniques and compass joint selection, insulation coordination, stretch grading, moisture sealing, and testing of joint for 11 kVA to 132 kV application. Stakeholder and application used by utilities, contractors, and OEMs in grid expansion, cable repairs, and renewable energy integration projects across industrialized region. Overview of high voltage underground cable system architecture and function of modern HV networks. Structure of HV cables composed of a conductor, usually aluminum or copper, PREPR insulation, semiconducting screen metallic shields, and outer PE and PVC jacket for mechanical protection. Voltage classes and application used for transmission and sub transmission. 11 kV to 400 kV underground HV system connect substation, renewable plants, and critical infrastructure in urban zones. Thermal and electrical cable design optimization, ampacity, dielectric strength, and heat dissipation through insulation selection and laying configuration. Network topology. Common arrangement includes radials, ring main, and meshed configuration to ensure supply continuity and fault tolerance. Why jointing material risk and reliability. Critical role of joint in HV network performance. Weakness link in the system. Cable joints are statistically the most vulnerable component in HV underground system, responsible for over 60% of insulation related failures in field studies. Mechanical and electrical stress stress point. Improper alignment or incomplete stress controls can lead to localized field enhancement. Partial discharge or breakdown of insulation material. Thermal and environmental effect. Temperature cycling, moisture ingress, and soil movement impose thermal mechanical stress and the accelerator joint aging. Ability and grid availability. High quality joining directly correlates with the network uptime and safety, especially in dense urban grid where maintenance windows are minimal. Fundamental principles of HV cable jointing, engineering integrating and performance assurance, electrical continuity, ensuring seamless current flow between conductor without introducing resistive hotspot. Crimping or compression connectors are used to achieve low resistance bond. Insulation integrating joint insulation must replicate the dielectric strength of the cable itself. Insulation materials are etched and molded to prevent field distortion. Stress control. Stress control turbine or mastic distributed. electric field gradient, eliminating localized high stress point that could cause partial discharge, sealing and protection, moisture ingrains prevention through heat strings or cold strings, seals ensures long-term reliability even in humid or submerged environments. Types of high voltage cable joints and techniques. Configuration and application in modern networks. Straight inline joints used to connect two cables selection of identical type and voltage class, ensuring continuity, conductor insulation and screen layer, common in network extension and repairs. Transition joints facilities connection between dissimilar cable types such as PALC or XLPE using specialized stress grading and sealing method. Branch T joint enable branching of one main line to two or more feeders, common in distribution substation and ring main networks for load flexibility. Shield break and cross bonding joints applied in long transmission circuits to manage induced voltage in metallic sheath and improve system efficiency. Cable preparation, conductor screen and armors, precision and cleanness in joint operation, conductor preparation, insulation stripping, screen treatment and armors and sheet handling, conduction preparation. Conductors are cut, squared and cleaned with a non-variable wipe to remove oxidation, comparison or mechanical connectors are then fitted using calibrated tools for consistent torque. Insulation stripping. Insulation removal requires controlled depth coating to prevent damages to semiconductor or dielectric layers. Specialized peeling tools ensures uniform surface. Screen treatment. Semiconductor screens are charmed and smooth to prevent dielectric stress connect. Carbon reducers must be thoroughly removed before applying stress control components. Aromas and sheath handling. Aromas wire and the outer sheath are carefully removed to maintain mechanical strength and grounding unity. Improper handling can compromise joints, sealing and integrating. Stress control in high voltage cable joint managing electric field distribution of for long width, electrical stress management, electrical field intensity peak at insulation discontinuous, stress control materials, smooth potential gradient, reducing the risk of partial discharge. Field grading method. Two main techniques: resistive, using semiconductor layer and capacitive, using geometric or dielectric shaping. Stress control to balance field distribution. Components used: stress control tube, tape, and mastic provides control resistive and elasticity to distribute electrical field safely within the joint bodies. Importance in reliability. Improper stress management leads to local overheating, corona inspection, and joint failure, making these steps essential to cable longevity. Joint sealing and environmental protection, defending agent moisture and contamination, chemical mechanical stress, moisture ingress prevention, mechanical protection, corrosion and mechanical resistance testing and verification. Water penetration is major causes of joint failures. Heat strings and cold strings tubes with active linear forms, protection shells, metal checkage, reinforced tape, joint physically damage, soil pressures, and rodent interfaces in joint installation technology, heat strings and cold strings, and pre-module joints. Modern methods for reliable HV joints, heat strings joints, cold strings joints, pre-module slip-on joints, technologies, selections, testing and quality assurance procedure, ensuring long-term performance, safety of HV joints, visual and dimensional inspection, electrical testing, partial discharge and tan and measurement document and flexibility. Safety practice and worksite protocols, protection personnel and equipment during HV jointing, worksite preparation, establish exclusion zones and earthing procedure before in work, verify circuit integration using approved The HV detectors, environmental control jointing should be occurs in clean and dry temperature controlled condition using tensor cable jointing way to prevent moisture and containment. Emerged and permit procedure. All works close permanent to work, lockout, tagout, protocol and site emergency response risking live environment. Conclusion excellence in high voltage cable jointing, integration of core principle, emphasis of training and standards, technologies evolution, and commitment of life cycle reliability. Thank you.